you check the live stream? Oh, on the photos. Good.
Hello guys, happy to see everyone here, especially with this horribly rainy morning in Kochi. Along with that, a maze of a venue. To be honest, I was just letting Mark know that if you want to make like a hideout or something, this is a place to make a hideout, not an office. Alright, so really happy to see that people have actually joined in, despite of the rain and the traffic outside. Welcome to the FOSS Meetup in Kochi, and this is for the month of August, right?
Yes, we are.
Yeah, right. And so I am Andrew. I am the CTO at Hopscotch. Hopscotch is an API testing platform which is open source. I'm going to stop with my advertisement over there. All right. And along with other FOSS guys have sent us basically a presentation to basically show. So welcome to FOSS Meetup. By the way, if it sounds really weird, I'm basically just reacting to this presentation blind along with you guys. Alright. So, yeah, so if any one of you here do not know what FOSS United is, it is a community of developers and designers and people around tech to promote free and open source software and their usage in India. FOSS United runs a couple of meetups, grants. They have a couple of programs like Mon School, FOSS Clubs, and they take part in updating public policy and talking with companies in terms of adoption of the FOSS. Right. And along with that, FOSS United also conducts events. So you are in one of the monthly FOSS meetups. This happens in many different cities. There's in Bangalore. I think there's one in Chennai. I think the Chennai one is happening today as well. That's happening in a lot of cities. You can check where all of those are happening in fossunited.org. They're also having the India FOSS conference. The next one will be on October in Bangalore. And then there is also an annual City FOSS conference, which is basically like how the monthly meetups were, but on a much more bigger scale, which happens every year. And FOSS, which is basically a hackathon in which we basically build FOSS software in a span of like 2 days. The last one kind of got over in April in Bangalore. So these are the numbers. So is this from the past year? Okay. Nobody cares. Okay, these are the city chapters which are where the city monthly meetups and the city FOSS conferences are basically held. So that's that. And FOSS United provides grants for high quality FOSS projects in India. So that is there, and more numbers. And they also run programs like Mon School, which is like an online learning platform for like learning coding and stuff. And they also are kind of looking to expanding the courses right now, and there's like a 1 lakh grant for anyone who is interested in building courses. Again, more numbers. Vishal is going to be killing me. Yeah. So yeah, public policy. FOSS United basically goes through a lot of public policy stuff. Yada yada yada. I think everyone here are engineers and not really worried about public policy, so I'm not going to speak too much about it. And then they are also working on FOSS for NGOs, and they are working on different initiatives for that. Oasis is a new one, which is actually happening right now. Along with that, there is the FOSS Pledge, in which organizations can pledge to encourage the use of FOSS projects and also talk about them in public so that the adoption of FOSS can be increased. Along with that, FOSS United provides a job portal. That's one thing. These are the industry partners. Of course, I had to show them. Cool. There's a monthly newsletter for FOSS United. Just go to fossunited.org/newsletter to find out monthly happening events. and things happening in the FOSS space and also the FOSS in India space. Yeah, as I said before, India FOSS is happening this year. This is the third edition of it. It's happening on 28th and 29th in the Enhance Convention Center in Bangalore. I think the tickets are basically up. If you want to register for it, just go to indiapost.net. I think we are still in the early bird ticket stuff, right? Yeah, so
Early bird.
yeah, so if you want to get tickets, I think this is a good time. Yeah, so if you are interested in coming to Bangalore, having a talk, having discussions, that could be cool. And more numbers. Yeah, okay. And then there is the FOSS Club initiative where they are actually planning on expanding to campuses to basically encourage the FOSS and building a college club with that. Yeah, and you can follow FOSS United in basically the following internet stuff. Right. Yeah, that's about it. Alright. Okay. Now that we are out of the way with this, let's get into our talks, which is what we are here for. So I welcome Aldrin Jensen. He will be talking about stable diffusion and how to get started with open source image generation tools.
Wait. Just hang on.
Okay, cool.
You need to share your screen, right? Yeah.
I mean, what?
No, you're the first talk.
Yeah,
This is the talk.
So
Yeah.
I forgot
After
about
the
that.
talk.
Just give us 5 minutes and we'll get started, okay? Do you want to talk about?
I'm now going to be using this opportunity to talk about hopscotch, even though my team would absolutely love that.
Maybe you want to talk about that presentation a little more, those numbers.
You missed the opportunity there.
Let's
Wait,
do
wait.
the FOSS pledge.
And any of the FOSS United guys, if you are watching the stream, if you guys send us a pledge, I will make sure that that is respected. We can bring up morning school assembly vibes.
Are you connected on your?
Yeah, it's already connected.
No, is it? No,
Just
is he?
go to Jitsi.
No, are you connected on the? Just hang on.
Yeah,
Let me just. Transfer.
We just
Okay, cool. So after all the technical difficulties are sorted, I'm handing off the stage to Aldrin Jensen. He'll be talking about stable diffusion and the situation with the open source AI image generation tools. Apparently, he's an art user. All right. So,
Yay!
okay, I started a sort of a warrior. I'm bringing Aldrin. I'm welcoming Aldrin to the stage. Everyone, just give a round of applause.
Full screen is. How do you full screen it? How do you full screen?
So thank you, Andrew, for that for the intro.
Wait. You see how the this is proper full screen. How do I go in full screen? F11?
Full screen.
F11.
What function of your?
Function F11.
Yeah.
Oh, okay, got it.
You can do
And
Windows
Alt.
tab. Windows
Yeah. And let me just see all.
Okay. So can we start?
Yeah, we can start. Sorry.
Okay. So before we start, I would encourage everyone sitting in a corner to maybe come to this side or at least to the front, because after a while I'll be screen sharing. So it would be best if we could come forward. Yeah. Great. Okay. So once again, hello everyone. My name is Aldrin, and today we'll be talking about AI-based image generation software. Okay. So let's get into it right away. So I have like a quick question. Is everyone here familiar with tools like Midjourney? Or can I get a can you please raise hand those who have used Midjourney or DALI or yeah. Okay, so like majority of everyone is familiar. Great. Nice. So basically, just to give a really quick recap, it's basically Midjourney is like a tool. From the DALI model from Google, sorry, OpenAI. Yeah, so this is from. So the thing about these two, so we don't really know the images in which they are trained. We don't know the parameters they use. We don't know the weights that they use to train their models. This this exercise is taken directly from the website. They just said they use 12 billion parameter version of GPT-3, but we do not know the dataset they use. What should I say? Inconsistent with the background. But then we never know. It's like proprietary stuff. We don't know, right? So then applications of these tools. As in, just forget the part about proprietary or open source. I first got access to the DALI, right? Initially there was a wait list. When I got first access, like I was impressed with ability. Like we could enter a prompt and it will actually generate something like a chair on the shape of an avocado, and we can get it. But then after a while it started to work. Okay, so this is something which we can explore for fun or for novelty. But then if you think about it, what could be the larger implications these could have? Do you guys think this is revolutionary, or that many industries would change because of it? I mean, these are like good questions about it. Let's look at a few examples of how this happened, right? Became extremely easy to do using these kind of image generation software. That is one. Another example of something similar is like Elon Musk with this new girlfriend, who's apparently Elon Musk himself has to come and saying like, I would never wear such an outfit, right? So that's it. Another example is this became like. Okay. But then let's skip the fun part of the novelty part. Let's think about industries. Like how could actual businesses be using tools like this to optimize costs or to enhance their workflow? So this is an example of here's a video. Okay, so like Marvel recently had a series called Secret Invasion, the one with then others will follow, and then a lot of artists will be losing their jobs. Right. So it's like a turning point kind of thing. There's a lot of backlash, but if you think about it from a company's perspective, it's like easy to optimize cost for them. And if you look at first glance, like, it seems like just like any other advertisement, right? Crazy thing is, this thing is entirely AI generated. We can notice that easily if you like really zoom in and look at their fingers, right? Okay, I can zoom. So we like generate like hands or fingers, right? So, and then the crazy thing is like, if you look at it at first glance, you will not even notice that this is a AI generated image, right? The one who made this poster, they said the actual generation part took just like 4 minutes, and then they took a few more hours to do the layouting. Layouting as in adding the logo, Kalyan's logo, and then some description underneath, etc. So crazy thing is they were able to do all of this within just a single day. But then if you're able to actually do a proper advertisement like this, they would need several days. You'll have to call in a lot of actors. You'll have to do makeup, give all the costumes, then camera, lighting, like so much. What should I say? Time-consuming activities. They were able to do it within just 1 day. So the point I'm trying to make here is that after this AI hype which came up last year, mainly last year, right, a lot of companies are looking at opportunities, and then so there's like a lot of possibilities we can do with it. So this is just a recap of what's happening around in Hollywood and around in those that are nearby us as well. There was also a prominent advertisement by Coca-Cola. I don't know how many of you saw it. Like it's like a 1.5 minute video of. Did anyone see that, like Coca-Cola advertisement? No. Okay, so I'll be linking to. I'll give a link to that at the end as well. Thing called stable diffusion. It's extremely popular in Fiverr nowadays. A lot of people saying, okay, I will build you something with stable diffusion, just pay me this much money. Like, so 8K and then 13K. Like, so there are a lot of people out there who are ready to offer services like that. Okay, so outline. We talk so a little bit of who am I? I am passionate about like free and open software. I've been using Linux for like the last 5 years or so. Currently, I'm building with a friend. I'm building a product for like automating job applications to make it easier to apply to company. Pull out your phone and then just web application. I'll show you. It's created a web application like this. It's basically a very clean, very minimal interface with which you can just try out just to get a taste of actually generating images just from a text. Okay. Scan the QR, just go to bit.ly/polisano. Okay. Yeah. About DALI by OpenAI. So both of these are text image generation software which are proprietary. Right. So Stable Diffusion is an open source alternative. It is made by Stability AI and Runway. Both these companies are pretty famous. Stability AI is like actual open version of an OpenAI, how it should happen, I would say. They do a lot of work on generative AI and LLM based software as well. Runway is a company which mostly focuses on research, and they have a product called Gen 1. Gen 1 is basically text to video generation up to 16 seconds of video just from a simple text. So, with that finding, based on this paper, high resolution image synthesis with latent diffusion model, that's the base paper. Based on. This is the paper. So, random noise. From random noise, based on the prompt, you'll be reaching to an image. Okay. So, what I did is consider stable diffusion like a model, just like any other ML model. Okay, you take a large data set of images which are annotated. Annotated as in, for each image you'll be having a pretty good description. Like for example, this is an image and then you have a description of it, like an alt text which you enter in a website, right? So you take thousands of, not thousands, like billions of billions. You modify the pixels slightly so that image becomes more and more distorted. So you apply some noise, you get one image. You apply noise to that one, you get another image which is more noisy. Eventually you go there until you get completely static noise. You do the steps like thousands of times and then you get like completely random noise. Then, based on this prompt, you're trying to reverse engineer it. So what the model actually learns is, it learns to identify noise and transform it slightly to get an image which is based on the prompt. So what you do is, you take the prompt, then you vectorize it, and then you create an embedding out of it. What that means is, suppose you have a sentence like, John is king, right? So when you vectorize it, you'll get an array of numbers. So like minus 0.1, minus 0.005, 0.985, 0.6, some numbers in it. Now this vectorization is a separate part. This was there even before the same whole thing. So you vectorize the number, then based on the number, you tweak it slightly with the reference image to get back to an image which is closer to the initial image which you used to train based on the prompt. This is a very high level algorithm. It's like much more complexity underneath it, but this should give you an intuition on how this works. From static noise based on the prompt, you're going to be training a model to actually generate an image which initially you had to compare. So this will be using a reinforcement model of deep learning technique. Midjourney actually uses RLHF, this is called reinforcement learning based on human feedback. That's why when you enter a prompt in Midjourney, you usually always get it in terms of 4, right? You get 4 images at once. And then when you choose one image to upscale, and when you do feed, there's an option called favorite too. So when you choose an image, that's actually signaling the AI saying, okay, out of these 4, this is the one which closely resembles. So based on it, it's improving continuously. So that's it. Yeah, that's how it works. So this is how stable diffusion works. So now let's come to the okay. So one obvious like a good solution. Give me a thing. Okay, so there's an easier way to get started. That is by using the field of generative AI. There are 3 main people who are like widely known. One is this guy called Automatic 11. There's another guy called Cavenderu who makes a lot of Google Colab notebooks for a lot of LLMs or generative AI stuff. And there's like one more guy who I am assuming if you were there for Korean Beyond Stock on Whisper event or not, a guy called Carnival. These 3 people are like basically like a web-based UI with which you can actually configure a lot of parameters to optimize your images. So right now I'm assuming all of you might have at least tried the initial link I gave, right? So that had like just one something better than this one as well. That is using this project. This is basically a Dockerized version of the same would be, right? This should be, I personally use this one. I found it like way easier to set up. And then even if there's some version mismatch issue, it's like super easy to, if you know Docker, it's like super easy to manage. I was just doing that. Okay, so now let's start like let's see how to actually use this. So basically, initially you take the Docker image, you do a Docker compose up, and then you would be getting a UI which should be resembling something like this. There would be some, I've added a few extensions here, but other than that, this should be the UI which you get when you just start using that project. I am recommending that project because it is the most popular, and so even if you face any issues or bugs, you can be rest assured that others would have already felt it the same, so it would have already be having a solution to the issues there. Okay, so this is the tool which you can use to generate like really awesome images using table diffusion. So I'll just talk about the main parts of it. The first one is called the prompt field. So here is where I'm not sure if it's visible. I'll just read aloud.
Can you just increase the size?
Yeah, sure. Yeah, there are a lot of elements. I'm not sure increasing the size, but anyway. So you can enter a prompt here, and then there's something called, this is the field for a negative prompt. So I'll show you how that works. So as in the example we saw about, let's just say if anyone is trying the other project, I would recommend you to hold on a bit. We are running on the same server, so let's see. So this is the prompt I tried for like a young boy eating ice cream, and then I added something called realistic. It's basically just a way to get much more realistic, closer to reality kind of shape. And then you got something like, okay, there's something like a biscuit here, right? So then we can add like a negative prompt here, or I'll show you another. Okay, so let's just say I added the pink as a negative prompt. So let's see what happens. So now it's going to be generating an image, and then it's just removed all the instances of pink from the whole image. So that's like the negative prompting. And then now I'll talk about a little bit about the parameters. Here we can control the width and height. So like right now it's a square image, right? So it's like 512 by 512. That's it. And then batch count is how many images you want to generate at once. Both of these are similar. If you do 2 by 2, you get 4 images at once. And then CFG's key, there are a few other parameters which for which we cannot really recommend what is the correct way to do. You'll have to tweak it yourself to get like better images. So one of them is our CFG scale. Usually it's recommended to keep something between 5 and 15. Usually, but then it varies depending on the style of image you want to create. And then similarly sampling steps. It is recommended to create at least around above 50. The more sampling steps you take, the more longer it will take the image to be generated, but more crisper or more, what should I say, more flexible the image should be actually. Okay, that's a contractor guy. Yeah. So, and then the seed value. Yeah, seed value, this is basically about when you want to preserve a style. Like for example, it's similar to the srand function which we may use in C or C++, right? How do you initialize a random number in C++? Basically use srand and then you assign it to the current time, right? So the idea is that if you have one kind of, see, earlier when you see the image version of a boy, it's much more realistic. Right now it's a little bit like a cartoony kind of little bit vibe, right? Yeah, so that's because when you say -1, it means like randomize each time. So if I do the generation once again, it will be like a different image because each time the seed is like different. But then if you want to have, okay, so if you want to like have like this kind of something similar style again, we just need to copy the seed. See, this is the seed which we are using right. Yeah, so we just copy that one and then we can like paste it here to get like very similar. So if I don't change any other parameters here, but generate it again, I should be getting an image which is almost like the exact similarity of the other. I mean, the same style I have there. So that is about seed value thing. Then what else? Okay, so this is like an absolute basics, right? So you can get started right away by just downloading the package and then just with these many parameters that I told. Then suppose if you want to go like one step beyond, right? Like how do you get actual realistic image like the Elon Musk thing which we saw? And also this one has like some issues, right? It is not like perfect. So how do you do that? So let's talk about that as well. Right. So moving on. So then the one crazy thing about having like open source models is that the community, right? They take your model, they rip it apart, they look inside, and then they build it back up in much better, more creative ways. So thing is like once the initial weights of the model was created, people started looking at it, then they started exploring it, and then they started making much better model, better as in with different like features. So like is everyone here familiar with fine tuning? What fine tuning is? Yeah, fine tuning. Yeah. Fine tuning. Okay. So quick recap. It's basically you have a deep learning model. Then the the end, towards the end, there'll be like a lot of different layers, which almost like you add extra images or whatever data to make it like much more optimized for a particular task. So this is a really cool site called CivitAI. You can run some models here. You basically go to you go to the view more section. So you'll get a lot of categories, so different kind of models here. Now all of these models are created for different purposes. There's a lot of it for anime or for like a specific kind of background, etc. Right. So this is like so a lot of different models are available. So if you want to check it out, just download the model, and then in this stable diffusion, this project you can just add the models in, and this is for I'll show you how it works. So yeah, so when I'm using it from this particular Debian service. So when you have that stable diffusion project, just add it in this models folder, and then when you hit the refresh with that same model, you should be getting it here. So this is what affects the generation the most. The model you use will be having the most impact on the generation of your image, and then everything else will be using to make it like fine tune it a little bit better. So so if you want to have, there are different models available for either if you want like a realistic faces, or if you want to generate like cars, right, or say particular types of clothing, or there are a lot of different models for like a traditional Indian woman, or like what's called a woman wearing sari, or like it's a lot of different there's a lot of possibility. I would suggest everyone to check this out. It's a really cool site. They just changed the UI a little bit very recently because it's a little bit slow. But then yeah, it's a lot of options to get to explore and try it out. I would give some recommendation. This is one called Protogen. This is very recommended in a lot of communities. Protogen model. It's a general purpose model, so you should be able to use it for a lot of different tasks. At the same time, it offers photorealism, which means the images generated will look pretty close to reality. Right? If you look at the face, it's very hard to decipher if you at first glance if it's an actual image or an AI generator. Okay, so that is one way to get started. Let's go. Right. But the only drawback of this is you would need at least a 6 GB of GPU to actually run this thing, right? So then, yeah, this may put us, it may be a little bit of difficulty for some of us. Like I personally used to do this initially on a Pentium CPU with 4 GB RAM, but yeah. So
when you say 6 GB, you mean the video RAM?
yeah, the video RAM. The GPU memory should be 6 GB. Other normal RAM, I think you need like only just 4 would do. The GPU is what is like the deciding factor basically. Yeah. So, but then no worries. There are like alternatives. So I've added a Google Colab link. Everyone is familiar with Google Colab, right? Yeah. So it's basically like a Python environment which you can run on Google service, and then it's like free. You get up to I think 12 GB of GPU for free. So it's like super easy. You can actually run the same automatic 1111 UI which I showed you right now. You can actually do that on Google Colab. Just need to like install the packages, and then you get the link, which when you click it, you will be having the same UI which I just showed earlier. So the reason I'm again talking about the automatic this is not the only option to generate images. There are other UIs similar to automatic learning. Then this is like extremely popular. So popular that in different communities under Reddit, right, in stable diffusion communities on Reddit, they would usually say, "Oh, bro, just use 50% noise strength in automatic learning." It almost became like a novel kind. It's just so hugely popular. And then if you can get accustomed to this particular UI, then every other UI usually will be able to take it up really quickly. Okay. So then let's have like a quick recap right now. So we talked about stable diffusion. It's basically an open source alternative to Midjourney and tools like DALL-E, with which what we're doing is we're generating an image from random noise based on a prompt. That's stable diffusion. The easiest way to get started would be something called automatic 1111's web UI. I'll be giving the link as well. And then the factor which affects most about your generation would be the model that you choose. Different models are optimized for different categories, for different styles. There are some general purposes model like Protogen that is showed. So you download a model, and then you add your prompt that you want to be. Then you can fine tune it better by adding negative prompts, or you can change the CFG scale, sampling method, etc. Now we can't really say okay this is the best numbers you have to use. No, it's more like a little bit of tweaking, try and error kind of thing. Something like I don't know, I'm not even get examples, but that is the main process that you can do. So now let's talk about how do you write better prompts, right? Because this definitely has an effect on the direction in which you want to guide the diffusion. If you remember seeing the other image, right? The alternate text was pretty large, right? So let's see what are the tips for that. So there are like four main tips. First one would be you have to be specific, and when I mean explicit, what I mean is like be as detailed as possible. Give maximum description. If you want the image to be like extremely realistic, just do like photorealistic HDR or like add like a lot of different styles. But just don't do something like cat or like white cat. Don't do that. Just to insert like white cat and then photorealistic HDR with some like if you think about Midjourney, right? You have an option to do like a lot of different parameters along with it, right? You can W hyphen AR something etc. So I would say use maximum. I'll give you examples for that. So this is like a site called Lexica.com. It's basically a place where a lot of people submit their artworks, which is created using stable diffusion. So you can just go to speed and then just click stable diffusion here. That means like you'll be able to get a lot of image inspirations. And then if you're interested in any one image, you can just click that image, and then that will show you like the prompt used. Right. So this is the prompt they use to generate this image. Then you'll also be able to see the seed value. Right. So you can basically take this prompt, take the seed value, and then you can put it in the stable diffusion on the UI which you showed. Then you should be able to get something similar. It may not be the exact same thing, but you should be able to do it. And even in the Civitai website, right, when you scroll downwards, you'll be able to see a lot of people generating these images using that particular model. Then when you click on any of that image, you'll be able to see the prompt they use along with yeah, the prompt. This is a positive prompt. See, it's like super big, right? Yeah, so they use this prompt along with even large to negative prompt. Then this is the model they use. They use this sampling, this scale, etc. It's a good way to get started, right? You'll be able to get inspiration from these photos. Then you can try slowly replicating it and maybe tweaking it here and there to generate the image that you want to. So that's one good way. And then yeah. Okay. Next one is would be to use different artist names. So like let's just say I have an image of a cat, then I want it to be as if painted by Picasso for some reason. Yeah. Okay. Yeah. So then what I do is like I basically check out like different artists and how and example of how their paintings looks like. So these are like so like Van Gogh paintings. So suppose I want an image which should be somewhere close by. I can just say like maybe use these parameters like in the style of Vincent Van Gogh, and then it should generate image which is closer to that style. So that's like one way. The other one is use extensive use of negative prompts. There are a lot of people who doesn't use negative prompts at all, and then they worry why their image has these distortions or these issues. So you can try using negative prompts. There are some other people who use negative prompts way more extensively than positive prompts. You can try out which one works for in your case. And then finally, tweaking the parameters in the main UI. I've kept it for the last one because you can get a lot of it just by changing the model and then just by adjusting the prompt. In the end, if still you want to make different variations, try tweaking the CFD scale, then the sampling method, sampling steps, etc. Okay, so these are the main 4 tips to get better images. I've also added like 2 blogs on like even more ideas on how you can improve your generations. So now let's move to a little bit of advanced features. Before that, is there any question? Like, is anything not clear? Is anything you should explain more?
Yeah, just a question. Can you like impose a style on an image that you took by yourself with stable diffusion?
Yeah, sure. Yeah, we can do that actually.
How does that work? Like?
Yeah, we're gonna be covering that. That's advanced section. Yeah, okay. So, is there any other question? I'll come to that. Any other question? No. Okay. Cool. So let's move on to the advanced section. Let's come. Yeah. So we are talking about even more cool stuff in the UI. It's mainly consists of these 6 parts. We have time, right? Yeah. Okay. So first one is called like LoRa. LoRa stands for like low rank adaptation. This has nothing to do with the LoRa which we hear in the electronics and communication part. This is basically about how do you impose a style on a particular image. So I'll show you an example. Quick tip, when you go to Civitai, by default it will show everything like all the models you want to use or including other things like LoRa. So you can just toggle it here to adjust. So by default when I say model, what I mean is like set point part. Okay, they will usually be ending an extension in .ckpt or .saved answer. And usually these models will be having at least several GB inside, at least 2 GB minimum they will be having. And then you download it and then you use it. Yeah. Now I'll show you what LoRa is. LoRa is basically how you impose a certain style to the image you generate. So for example, LoRa is really good for let's say you wanna have like portrait images of a particular person. So how do you make the face similar to a one particular person? So in that case, you can use a LoRa. There was a really good example of Harrison Ford. So you say a man riding a bike, and then you add a LoRa in the end, and then suddenly the man's face will be like Harrison Ford. But then very recently, I think 2 days ago, something they took down the model. I think they got some copyright issue. I'll show you another example in the same theory. So you can get LoRa's by going to this icon here, and then you'll have this tab called LoRa. You can download LoRa's from Civitai itself. Just filter LoRa, download a LoRa you like. I'll show an example of one LoRa which it's like kind of good. Yeah. Yeah. So it's like see the kind of the specific style. It's like the cute face and then little girl kind of vibe, right? So that is basically LoRa. And LoRa's will usually be only having a few hundred MB size. So this one is like 144 MB. So what it actually does is you take a model, you generate an image, and then you use LoRa on top of the generated image to get a particular style. Okay. So for an example, I can have it's this thing called Bamboo. It's like okay. It basically gives up a Japanese aura kind of vibe. Let's see. I'll maybe add. So this is how we use LoRa. You either click it here or just type LoRa and then LoRa name. You can download LoRa from Civitai again and then paste it the name here. Then you get like something like okay, let's see it without LoRa. So the lighting is like different. Like it's like a let's see one more. This bamboo light model is like I'd say like very minimal, but then so you see how the lighting is like different. It's like it may seem like minimal, but then there are like even powerful models. Like I really wanted to show this one. This one you can try it out. And then sometimes LoRa's will be having a trigger words like when you want the light to happen. So for example, this one is used with a small core animator. This is a good model if you want to create AI-based video generation, like small kind of thing using stable diffusion. This is a good model. And then they're suggesting using it with that particular one. So then this will apply styles to that. So these are like some other examples you can see there. And then let's look at the prompt as well. So see how in the end this LoRa kind of thing. So this is the main prompt, and they're saying use this particular LoRa. Okay. That's a way to copy styles to an image. Then the other, let's talk about even more other ways. So then there are two things called painting and image to imaging. Just I'll show you how to do that. So yeah, so these are ways by which you could replicate functionalities of things like Photoshop, right? Using just text. So basically you add an image here, and then you can try to like change. For example, you add an image of a boy looking at a bird, and then you add an image and you just draw a circle around the image, and you say change that image to something else, like let's just say a peacock or whatever, something like that. So that actually works. That's called like image. That would command is called in painting. Then image to image means you take an image and then you apply a prompt on the whole image, not just on the mask. So for example, I could show an image. Maybe at the end I'll show it. Okay. Then there's something called control net. Control net is like a really this came out as a huge thing recently. So control net is where how you can have a generation be guided based on a reference image. So it's not like you're applying a style on the reference image. You're guiding the initial generation based on let's just say a pose of that reference image. For example, I could add a control net image of a person doing like this, like holding his chin or something. Then I'm saying a man looking at the camera as a prompt. So then what happens is the final output will be a man looking at the camera, but then he'll be holding like this. So it's like we are guiding the image, saying follow this reference prompt. Okay. So that's a good way. And then you can use all of this together. So you can use control net along with the LoRa. So if I want, I can say Harrison Ford looking at the camera, but then he'll be holding a face like this. So that's like one message you can check out. And then this deform. This is like a really cool thing called deform. This became like really popular on YouTube and Instagram Shorts mainly. YouTube. Yeah. This is about how you can stitch a lot of images generated using stable diffusion together, and then create a video out of it. So it looks really cool. And yeah, so this is a video I created like yesterday. So see how it's like transitioning very quickly, right? It looks like kind of interesting, right? So, and also you can do it in the same UI itself. How you do that is basically go to this before and
Is
and
this
then
part of stable diffusion, that thing that you showed right now?
yeah, that's an video I created. Yeah.
Oh, no, is it part of the stable diffusion kind of feature, creating these videos?
Yeah,
No,
so,
right?
yeah, so it's basically like we are creating a lot of different images and then
Okay.
stitching them together. So stable diffusion does the generating part.
That is not the stitching part.
Stitching part also we can do in the same UI.
Oh, you can do that.
No, like what is doing the stitching?
So it's
We have a model that is strictly trying to figure out what this, how to associate
Yeah,
images.
because the transitions were like really
yeah,
fluid, right?
yeah, exactly. I'll show you how that is. So basically, this is the prompt I gave for that. Okay, so I'm not sure if it's so much legible. So basically, what he's saying is, I want the initial frame to be a tiny cute bunny. I'm saying I want a 30th frame to be something of a cat. I'm saying 60th from should be 99. So what it actually does is, based on this interval, it will try to generate images which goes on transitioning from the first one to the next one. So we got like let's say 30 different images are generated by the model, okay, which goes on transition. And then we can, if you want, we can actually stitch it up ourselves using any video editing software. But then,
So how many images did you create originally? 4? Is that 1, 2?
No, no,
It's not
no,
generating
no.
anything. The model itself is generating. it
Oh,
all.
okay.
I don't know. The thing is like,
No, I think he's generated 4
Yeah.
thing, and the stitching is also done.
4 timestamps.
Yeah,
0, 30,
so that's
and
like
60 and
4 distinct images.
we actually generated 120 images.
Okay.
We actually generated 120 images, but then we don't have to give prompts for each 120 images. It's the same like 4 timestamps. We give 4 prompts saying these
4 prompts of 4
Huh,
images, and
huh.
the ones in between are generated by
Yes, exactly. And that is generated such that the transition seems such
Got it,
seamless.
got it.
Right. So that is the idea.
Got it.
And then this particular UI, stable diffusion UI, right? It even
So if
gives
you
a-
think about
yeah.
it, we don't have real control over the transition, those transitionary images, right? Because those 4 images that you created, we have full control because we gave it the prompts and we got the 4 images. So the ones in between, like you said,
Yeah.
that 120 minus 4, those are being like that's completely stable diffusion deciding like these are the images in between. Right?
There is a way we can influence it further as well. We can add this along with control net. So we can say, let's say transition should be like at this particular instance you use this control net to guide it. So like our transition to be like enlarging or something. We can do that to an extent. But what I found is also you can do. Right now I give in the intervals of 30, right? 0, 30. We can make it even shorter, right? Sure. That could work. Yeah, but then I would say like based on the model generating, it seems like much better and cleaner. I tried the other one, then the model generating seems much more clear and much more seamless to me. Yeah. So that is D4. That's a cool way to make this even better. You take a normal video of you, let's say walking. You take a screenshot of one particular frame. You feed that as the initial prompt. As in, you just have to actually insert the very first image you want. Then from that image, you can transition to a totally different one and then create it. So it'll be really cool when you stitch it back. Right. So then these are like some really cool resources. I would really suggest going to this Reddit subreddit r/stable diffusion. You get a lot of inspiration of people doing like really amazing things with this technology. Yeah, and then this is the GitHub repo of the code of the project which I showed you earlier. This is basically done with Python. It's like a Streamlit. Anyone familiar with Streamlit library in Python? Yeah, it's like a really cool way to make awesome UIs with Python. And then it is actually using behind the scenes the same this one. We can give this as an API as well. So there are APIs for stability AI, which is I think you have to pay, right? You get free credits, but then you have to pay
Some free credits.
you get some free credits. But if you do something like this, then you get the API by default. So you can do everything which we did like manually using triggers, etc. You can do that using code. So that's how this project is created. Basically, I've added the code for that as well. Okay, so let's go to the conclusion of this. So let's talk about the conclusion part. Basically, I would say right now, all of us, right, we got like an incredible opportunity. This is not like some people come at this with giving Photoshop, right? This is not like Photoshop. It's just made it like much more easier and accessible to everyone, right? We don't need to have like a powerful server to run these things. We can use Google Colab, or if you have like a 360 GPU, or locally we can do that. And then the possibilities we can create is like endless. There are so many. Just go to that subreddit. I would really recommend everyone to try it out, and then maybe sort that based on popularity at all time. You'll be blown away by the awesome things which people are. At the same time, we see a lot of misinformation spreading, and we are right now at a stage where we can't really believe anything which we see. right? How do we know it's AI generated or not? A lot of content which we see on websites mostly are like AI generated. And when AI generated, it generates really well. That's such that the SEO is optimized as well. So when you search for something, it would use the article which used to come at the top of a Google result may not be even authentic, right? And then even maybe did anyone watch the Netflix show called John is Awful? And anyone the Black Mirror episode? No. Okay, so it's basically about how in the future the content will be more personalized and more AI generated. So each of us could get our own particular set of series or episodes based on our taste, personalized for us. But then we'll be living in a bubble kind of thing. Right? It'll be amplifying what we believe, what we want to know more and more. So I don't want to be pessimistic. I'm talking to you all who are like, you know, particularly enthusiastic and knowledgeable about technology. The common man can easily be confused. Like I often like clarify a lot of my relatives. Okay, this is AI and this is not real. You don't believe that. It's a scam message. Don't believe. So we know that it's not magic. We know like how it works right now. We know how easy it is to get started. I'll end with like this one example. This is an example of this is an alternate video of me playing a guitar. Listening. Can you just check out like how like consistent it looks? Yeah, understand, right? I got it on like this one first. It's like a deepfake video. I got it on like very first try with just one image of Robert Downey Jr. I played 1 second ago. Just check the consistency. Yes. See, there's no like usually the skin should be white, but then it's like blended like very nicely, right? It's very hard to decipher, right? The point I'm trying to make is that the technologies are there. Everything is open source. I didn't use any proof. Everything is open source. It's like super easy to make. Right?
It's wearing glasses as well, right?
Yeah, exactly.
The same glasses that he's wearing.
Yeah, and even the hair is like, yeah, it's like the first time I tested, I was like blown away. It's like super easy to do. The reason I'm trying to like, say that, I mean, this technically doesn't come under stable differences, but for the overall like AI-based image generation, like that. The technology out there, there's so much we can do, but just need to be like wary about. It's like they say, right? There's like great power out there. Just be responsible about how we use. So that would be with that. I think I came to this. Thank you guys for that. Would be.
So you said that you were using Pentium machine to generate all of this. Is that what you were saying?
No. Right now I'm using this is an i7 processor probably. But then I'm saying I used to be having a Pentium laptop, so I can relate when someone says like 6 GB GPU. But with Google Colab, I think it should work even on Pentium machines. So it should. Yeah, I just want to give a shout out to David and Mark. Like, I was a little bit nervous about the talk, so they guys helped me out. And then I want to call out the Teddy sir. He's a teacher in my college. It's over thanks to him that I first got in this exploratory phase. He gave me access to a 8 GB GPU server in our college, so that was like a starting point for me to explore around. And finally, so he's not here, but that's the one say, like I got really inspired by reading his blog. So you guys can check. You guys can find me everywhere on like this Aldrin Jensen, no spaces, no ARDR and anything. I also have a blog. I don't usually write too much, but you can check it out. I would suggest everyone to try out these things. I will send the PDF as well. Just try out, go create stuff, share it on socials, tag me, Twitter or Instagram, whatever. I'd like to see what you guys do.
Having one question, you just mentioned about 8 GB, right? So was it, again, 8 GB, was it just normal RAM or was it GPU RAM?
VRAM.
It's 6 GB, minimum 6 GB GPU. 8 GB GPU is recommended, you can try. At least 6 GB GPU of VRAM, so like NVIDIA graphics card.
So that particular gave you access to that VRAM, basically.
Yeah.
The GPU.
Yeah, like this project which we see here. This is running on the Model Engineering College service right now. An 8 GB.
Is it 3080?
No, it's I'll show you.
It's 1060, 1080?
It's an
2080?
So I didn't know that we had 8 GB of, I mean,
It's
I know it comes with
RTX
6
4000.
GB and 12.
Oh, quadro, 4.
4?
So
It's not a GeForce, right?
No, this is actually like not much of a server, but at the same time it's pretty good to like get started.
Yeah.
It's like Quadro RTX 4000. This is the yeah.
What is this?
Quadro RTX 4000. But this is like an entry level workstation kind of thing. Yeah, it's not much. But at the same time,
It's good enough, yeah.
But then to get started, it's like huge. Like I even tried some LLM stuff locally, hosting LLM on this. Didn't work out. Latency was like terribly there. Yeah. But at the same time, it's like good to explore. And, so yeah, that would be. Is there any other question? Okay, so okay then guys, like that will be. I hope you found it useful.
nothing ever changed because the drivers, the colors, and all work itself. Because the driver for the scenic, I tried and tried and it's hard. I didn't get something. No, no, you are not the. I got something which is like colors wrong. This camera is very interesting. So you have a full feature. This is not something I do full time. This is just for one time. I just do for 2 hours. Right? So I want to put it on the floor. And then I started using a cluster. My own cluster. No, it's Raspberry Pi base one. Then I built two clusters. This is this is a Raspberry Pi thing. So this is a normal Raspberry Pi. This is an overclock version. Okay, overclock. So I put an actual overclock. So the chiller I changed the it's wafer cooled and all that. And then because there was another project I was working on where we were sending some microsatellites. So this is this is a cluster for that. But I took it on the same Raspberry Pi. I changed the CPU and sorted it. What? You said right? That's right. That's right. No, no, helium.
Am I live?
Yeah, we're always right.
The audio is on, right?
Yeah, the audio is on.
Yeah. All right. Thank you, Aldrin, for the amazing talk, along with creating a little bit of existential crisis on me regarding AI. Not to be able to believe anything which is on the internet. All right. Now we have the exact opposite of that. We have asynchronous. So the others will be talking about asynchronous programming on Rust. So yeah, go.
Hey everyone, so myself Devda Chennai. I work at a company called ByteBeam. We build an IoT platform. It's kind of like a data pipeline that you can subscribe to and send your data. It's a startup. We do some crazy stuff and we build things in Rust. So I hope someone here, like, can you raise your hands if you know of the Rust programming language? Okay, fine. Yeah, so it's a systems level programming language, quite similar to C and C++. It's not like Python or Go where you have like a runtime and things like that. You have even more control. But at the same time, it's unlike C and C++ because it takes away a lot of the troubles related to it. It makes it easier to work with. As a developer, you don't have to deal with different build chains, things like that. Yeah, so today we'll be talking about a very specific part of the Rust programming language, which is related to asynchronous programming. Yeah, you can transfer the learnings that you get from here to other programming languages because it's not just in Rust, you have async programming concepts, you have it in other languages, including C and Java, JavaScript, Python. So yeah, so to get a gist of what I'm going to be talking about, let's start with a basic understanding of computing. So in computing, if you have multiple cores, right? What do I mean by multiple cores? CPU cores, right? If let's say you have 2 CPU cores, the operating system allows you to multiply that, right? By using the concept of threads. So I hope you have heard of multi-threading, right? Yeah. So multi-threading is basically trying to extrapolate the number of cores that you have on your system and run things kind of parallelly. It's not actually parallel because as I'm illustrating here, right? Parallel literally means you have two cores which are running two tasks at the same time. Whereas concurrent means which is what is happening with threads, or in our case async tasks. What's happening is you do a task, then you yield for a while, or you give away control, another task runs, and then you go back to the task that you were running earlier. Right? So what would this help with? Any ideas? What would asynchronous programming or concurrency help with?
API calls.
Huh?
API calls.
API calls. Okay. So, like web servers, right? How many users are trying to log into Facebook at a time, right? If you are doing multi-threading for every user, let's not talk about multi-threading. Let's talk about if every user had to have a core dedicated to them, right, to service their requests. How many cores would you require? Right? Billions. And which CPU has a billion core, or like which server set has billions, right? Billion cores. It's literally impossible, and you don't require that much overhead. That is where the concept of concurrency comes in. If you have multi-threading, right, the operating system deals with it for you. It decides which request gets that resource, right? Which thread has to run on the CPU at that moment, right? That is dealt with by using concurrency, the concept of threads. The thread is managed by the operating system, and that is what is being illustrated right underneath. Right? Adding on top of it is the concept of green threads. Right? Green threads allow you to basically do the same thing, but you don't have to hand over control to the operating system. You don't have to say to the operating system, deal with this for me. Right? You can do it on your own. Right? Inside the process that you are running, you have complete control over which request gets run, and that means that you don't have to do memory shifting. So that's the concept of context, right? Whenever you're running a process, you have to have some memory associated with it. What happens with multi-threading, or when the operating system is in control, is basically you have to move stuff from what is known as user space into kernel space, right? That's some copying, some cloning, all of that is happening in there. You don't want to be doing that all the time. So it's better to have green threads if you want to do quick and very minute changes, right? So if you're doing small tasks, it's better to have green threads than to have operating system threads. So OS threads are almost the norm when you're writing things that are long running, right? Tasks that are long running. Whereas if your tasks are very short, it's better to have green threads. Let's talk about some keywords, right? In most programming languages, including Python, you'll have read code which has these concepts, right? Async, right? Which basically tells the compiler that we are going to define an asynchronous block right afterwards. And there is await, which is basically telling the compiler that wait here for a while till this thing resolves, right? You can go to another task if something else is happening on a certain different thread, right? So different, not operating system thread, green thread. Yeah, and run that. Give that more. Yeah. So okay. Threads, the operating system does this preemptively. Any idea what is preemptive? Can anyone define what is preemptive?
Before completion.
Huh?
It stops before completion.
Which stops before completion, right?
Yeah.
And what is non-preemptive?
It goes until the process is over.
Until the task is completed. Okay. The opposite of it waits until. So there are two concepts that are important here. One is cooperative and the other is non-cooperative. So cooperative multitasking, which is what asynchronous and the use of async await mainly is for, allows you to write programs wherein you are giving control from the programmer's end to whoever is managing to say move from here to the other. I'm done with work now. You can move from here to the next task. That is what await is for basically. An async block, until it completes, you are going to wait, and then once that resolves, you're moving to the next task. Yeah, I kind of understand that this is getting a bit boring, but yeah, let's go into some illustrations. Maybe that will help. Right. So yeah, runtimes, right? The operating system is kind of similar here. Like operating system also takes tasks or processes or threads, right? And then runs them in literally looking like, it looks like parallel threads, right? But it's actually concurrent here. You will run one thread, then you will hand over control to another thread, and the operating system is preemptive or non-cooperative, which means it will stop a thing, give it to another, stop a process and give it to another, give resources to another process, right? By using scheduling algorithms. So in operating systems, you might have heard of scheduling algorithms like round robin. Right. So there are many other scheduling algorithms. Similarly, the operating system does that for us. Whereas inside your process, when you're using a reactor, right, to handle green threads, you're doing something similar. You're handing a task to that reactor, and the task will allot a thread that it has to run on. So resources are being managed by this reactor. Right. Let's look at some more illustrations. I've tried to make as many illustrations as possible. So when I started off writing asynchronous programming, right, I made a lot of mistakes. Everyone makes mistakes and everyone learns from them. So what I wrote, what I thought was basically if I wrote task 1.await and then I wrote task 2.await, both tasks would run at the same time. But that's not what happens. So task 1 takes up till t1 seconds to complete. Right? It goes from 0 to 100% completion, and then t2 starts. Right? Task 2 starts and ends at t2 seconds. Right? This is not what you probably wanted. What you instead might have wanted is let both tasks run, and then we'll wait. Then we'll get both results, which is what join lets you do. Join allows you to take two asynchronous tasks and merge them together, and once both of them have completed is when you will get the result. So even though task 1 completed at t1, the result of this will be resolved only at the end of t2 because you have to finish the second task as well. The same, if t1 was larger than t2, you would get the result at t1. Right? So I hope that illustration is more knowledge, like more understandable. Okay. Similarly, let's say you don't actually want the slowest resolver. You want the quickest resolver. Who resolves or like who gives you the result the earliest, right? Because you are basically waiting for something, and that is what asynchronous programming is all about. You can have a select block, right? Select block is like a race. You're running a race, and the quickest to reach the finish line is when that race ends. The other task gets cancelled. Cancelled as in you don't want the result. You're like, okay, throw this away. And you can use the result of this to do more further computation, right? That's what this is illustrating here, this code block here. Then there's also the concept of spawning. So thread spawning, right? What is thread spawning? You're creating a new thread, you're passing some computation to that thread, and everything runs on that thread. You are not very considerate of what actually is happening on that thread. Right? Your process, whoever the parent process is, has created a child thread, and you don't care about what's the result over there. The same concept here as well, where you have a task 1, right? The moment there is an await block inside that task 1, right? Control is yielded to task 2, or whoever other task is running in the same reactor, right? The reactor does all of that for you. And here, as you can see, since both are running in separate tasks, sorry, separate green threads, right? You have spawned a separate green thread here, basically. Both tasks will reach completion, right, at t1 and t2 seconds. That makes sense, right? And you can do further computation in those green threads, or you can use the concept of channels. Ever heard of the concept of channels? Channels? Okay. So in programming, multi-threaded programming, you have different tasks, right? Different threads running different tasks. And once those tasks complete, you might want to pass some kind of memory or some kind of object back to a central thread, right? So use a concept called channels. So what is a channel? Channel is the same as, let's say, a bridge, right? Wherein you pass a car on top of that bridge to the other side, right? Similarly, you have two roads. A car passes through the bridge to the other road. So two threads, you're passing one object, the other thread. That's basically what you're doing with channels. You can use the same concept here, where once you have completed task 1, you can pass an object from task 1 to task 2 or the opposite, right? Vice versa. And channels is something that helps you do that. You can also use other things, not just channels. There's the concept of a lock, right? Mutexes. Have you heard of mutexes? Yeah. So mutex is mutual exclusion. That is what it's shortened to. Yeah, mutual exclusion allows you to have two things running in contention of a certain object, and whoever wins that contention gets to hold control over that, right? So you can do things like a database, right? You can create a database, you can write data into that database, you can read data from that database, you can do all of that. So task 1 could basically be a request that is asking to get some data from the database. And task 2 could be writing some data into that database. Yeah, think whatever you want to think of that in those terms. Yeah, there are even further concepts that might be interesting to learn about. We just mentioned tasks, but I actually did not go much into depth because that would take us too much time here. And I just wanted to introduce you folks to asynchronous programming first. Then there's also the concept of futures, which is what actually is happening under the inside async blocks. You're basically creating a future. What is a future? It's basically a contract with the that the programmer is saying at this point you can in the future wait for something, right? So futures is what you are awaiting on. Tasks are what you are creating with those futures, and then streams, right? Streams are kind of similar to the concept of iterators. Have you heard of an iterator? Right? In Python, there's a for loops. You can wait on infinite loops, like infinite array of things, right? Where those infinite arrays are constantly being supplied. It's like a queue. You keep adding objects onto that queue. You keep popping objects out of those queue, right? So similarly, streams allow you to constantly keep adding things into the stream, and every few seconds, if you are polling that stream using the .await keyword, you will get an object out of that stream, right? So yeah, think whatever you want to think of it in those terms, but you are basically getting the basic idea of how servers are written in the modern age, right? So why am I talking about asynchronous Rust here? Right? Just trying to introduce everyone to the Rust programming language, of course. We have a Rust meetup which is happening in Kochi for a while now. Mark, Andrew, we have all been participants there. We try to teach the Rust programming language and evangelize it to anyone who's interested, because we see that there's a very huge scope to the programming language, right? that can be exploited by all of us techies here, right? So if you are interested, I hope you explore further into the programming language. Also, asynchronous programming as a concept is taking wings right now. Like, it is changing how programming is done, and hopefully you will also get to explore it in a short while from now. Yeah, thanks. Any questions?
Actually, I didn't actually understand what is the difference between this thread and this
Yeah. So, okay. That's. I think I showed that in that image. Right. So yeah, as you can see, the OS thread, right, is what is handled by the operating system. Right. It creates multiple threads and allows you to run tasks on those threads. Right. Whereas async tasks are handled by the process itself, where the process creates its own reactor, right, its own runtime, and then handles separate threads, right, not operating system threads, but an abstraction above that thread, where each thread gets to run these. Like, it's kind of similar to an operating system thread, but it's all being handled by the process itself. So you don't have to do memory switching. You don't have to switch between the processes, that's the user space in memory, and move it to kernel space in memory. So like, that's like a boundary, right? Operating systems create a boundary so that hackers or whoever is interested in getting data from the operating system, like, okay, so in operating systems, right, you are running multiple processes at the same time. So you would not want to have a process running in such a way that it can handle the memory of another process, a completely different process. Let's say you are running a malware on your operating system. The operating system creates boundaries so that that malware will not have access to, let's say, your password box or password safety or whatever application you're using, right? Because both processes are running on the same operating system. They have kind of the similar memory, but then operating system handles all of these things in such a way that there's a boundary across the memory that these processes are allotted. When you are creating a thread, you are basically creating a memory location inside the kernel, right, which is highly secure. The operating system has to keep it secure for these reasons, and there's similar memory that is allotted to the user space, right, to the process itself, which it has even more control over, right? When it wants to access the thread, right, when the thread is running inside the CPU, right, which the operating system is controlling, and I have to illustrate this further, but is there like a pen and paper that I can use here? I think actually we should take this out because I kind of have some trouble stating it with words. But basically the operating system has to have total control over it. That is why it can't let the process run in user space. It has to move it into kernel space, then run it. Which is not good because then like you are doing copying from here to there all the time. I hope that kind of made sense. I'll illustrate it to you further.
Can you give some examples on how asynchronous programming is affecting in the recent times? You mentioned, right?
Yeah. So let's say you have an operating system, right, that is being used to run a server with a build like Nginx, right? A server like Nginx, right? Have you heard of Nginx?
Yeah.
Yeah. So Nginx is a web server. It's running all of these things. If it was only using threads, right? For each and every thread, you will basically have to create an OS thread. Like each and every request, you'll have to create a separate OS thread to handle that particular request, right? Every time you will tell the operating system create a thread there.
Just clarify, must be like in the recent years you said, right? Some major innovations are coming.
Yeah, which is when they moved it, right, to asynchronous programming. I think I can take some help of some blogs here. they're saying that they boosted the performance of Nginx by 9 times by using a thread pool instead of using a single thread or like multi-threading. Yeah. So yeah, when you are writing multi-user applications, right, with the scales that you are having these days, right, you will have to serve like millions of users at a time, which means you have to create millions of threads, and creating operating system threads, right, is impractical because then there's like a lot of overhead that goes in, right? Each thread you have to provide a PID, you have to provide a lot of resources from the operating system side. Whereas with green threads, you don't have to do that. You are just having like a few operating system threads, and then you are handling a thread pool by using the reactor, right? The reactor handles this thread pool and provides the resources that these asynchronous threads or these green threads want. And the green thread, all the memory is being handled inside that reactor itself.
So is there any advantage to us managing this rather than letting the language do it? For example, in high level, even high, like JavaScript.
Let the language, as in, I did not get you.
Yeah, so in the case of
Let the operating system handle.
No. So let's just say we said about storing the state etc. in Rust. What if we just let the language do it? As in, let's just say we're using say JavaScript for example. Then
Even in
we
that
need to
case,
have
like
this right
even in the case of JavaScript, right? The JavaScript engine, that's V8, is basically using something similar, right? It's a runtime, right? And that runtime is allotting a thread pool and doing all of these asynchronous tasks through it, right? Workers and all of that concept is basically going through this, right? Service workers or whatever. Yeah. So it has a thread pool, and that in that thread pool, these asynchronous tasks are being run kind of parallelly by using the concepts of concurrency. Any other questions? Kind of know this is like very hard topic to teach in like 1 hour. Yeah. Thanks.
teaching all the people that you have.
We're using Brave, so left watermark. Okay, so delete it. Okay.
Specifically with the book.
FOSS United, and then
Dedicate as much
screen
time
share.
as possible. But if you're finding it boring, go for
Enter screen.
perspective. Then do as many projects as possible, starting with the projects in Tokyo. So Tokyo, when I studied programming. So Tokyo is the runtime. It's a runtime. It's a programming. It's a collection of. It's like a standard library for doing asynchronous programming.
Can you just change your screen as normal?
What you want to do is, but if you just
Yeah. 5 minutes restart.
try to build projects. Vishal also built a project.
Few minutes and restart.
Okay. They have to start a new club.
They have something called FOSS Club for students. I don't know.
No, why should they start a new club totally different from the club that they already have?
Foundation is within foundation. You saw Vishal Cup is there and you scale it.
That is a different person.
Yeah, politics.
No, they're expanding.
They are different. They want to be more. They want to look more. They got ID cards and everything.
No, that's because I actually followed this. So there is a call about the and
About the zero office.
no, not the tech calls, right hand not
Where is it?
it's near only, it's like 500, 600 station available. 500 of
And then
It's 30 now. 30. Streamers. Anyone watching stream? You could have put it in this your stream.
I should have put in that transfer.
But then somebody would be waiting there for 30 minutes and that's all.
That is what happened. No,
what numbers question
Question mark.
I mean, you guys minding me to skip.
I got I think they want to use this presentation as an example for other cities. This is like a complete discord kind of thing. This presentation The numbers. More numbers. More numbers. Nobody cares. The live stream will be like a full. That live stream as live stream is that won't be gone. Then I'll chop the one with the iPhone. It is like you can see that it is a microphone. Last week, quality was volume was gone. It was very strong. Very difficult to run. It didn't pick up anything. Actually, I don't like it. Oh, that you can think of, you can see in the live stream. If you click live, you can see it on that. But you have to scroll and find where it stops being. So I didn't edit it as a separate Oh, he was in 12th standard when I last met him. I didn't start right. Are you studying? Huh? Allala. It's closed. What? Fourth year already. The boy is completed since when he last met. Where is this coming from this audio? He's saying he can hear the audio.
ഈ മൈക്കിനാ
Right. I hope you guys had a good session basically to talk with each other and network. Now we are basically heading into our last talk for this month's meetup. It's about a thing called Alpha Drive. Is it called? Okay, cool.
I thought it was
I thought it was Alpha Drive
I
as well.
prepared the poster that way, and then he said, "No, there's no H in the thing." I was like, "Oh, okay."
Okay. Yeah. It's about Alpha Drive, a DIY way to enable cloud connectivity in legacy vehicles. Nice. Let's see what MBD has to say about it, but okay. So I'm welcoming Vishal Krishna onto the stage to basically talk about it.
Good afternoon. So today I'm here to present something that we made to you all. We are a team consisting of four, the three people there and myself. So this is so this in this presentation we will go through it in four sections. We'll first say, oh sorry,
It's not connected. It's not connected.
Screen
Mirroring.
mirroring.
Yeah, that's it.
Work തുടങ്ങട്ടെ. Once you start doing work, like real time work.
Okay, start.
Using
okay, so we'll go through this in four sections. First, I'll tell you what this is, and then I'll tell you what we are aiming to solve, and then I mean what we aim to solve. To be honest, then I'll tell you how we solved it, and how this is a DIY solution, as in how you can get cloud connectivity enabled in your cars through this using our solution. Okay. So we first say what this is. Okay. So what do I mean by cloud connectivity in vehicles? Okay. So you have a cloud. The cloud meaning the internet itself is the cloud, and then usually what all is connected to the cloud. You have your what do you call it? You have your phone, you have your laptop. Everything is connected to the cloud. If you think about it, you can actually communicate between these devices can communicate with each other, and you can control one device from another. Not entirely, obviously, but you can view some information of one device in another device and do all of that. So this thing is basically simple. We just add your car to the mix. Like we just connect your car also to this network, so that you can actually monitor your car and in the future hopefully control it from your other devices. So what is the current status of such systems in India? Okay, so we are just specifically focusing on India right now, and within India we are only focusing on the budget sector. Like you may be tempted to say, yeah, Tesla, you can control it through the app and all of that. Of course I know, okay, I accept, but we are not going to the expensive end of things, or we are not trying to go on a global scale here. We're just talking about India, and we are only talking about budget vehicles right now. So of course, as I just mentioned, this tech is really expensive to get in to the R&D and the manufacturing, and all of this tech is expensive. So any cars which have this tech are expensive to the end consumer. And then the whole point of this is that any solutions which exist today are closed source. There are no open source later on. So then there is the fragmentation. If you know, this fragmentation thing is the same as with Android manufacturers. So if you have this, you have lots of Android manufacturers, and they write firmware in lots of ways. They have the AOSP is customized in lots of ways. Xiaomi does MIUI, then Samsung does their One UI, and Pixel does .Android, and all of that. And the whole system is fragmented. And you as an app developer, when you try to write software for it, the your app ends up not being optimized. Okay, so that's why we see many games run slower on Androids versus iPhones and all of that. So the same thing applies here. We will also talk about that later on. So what are we aiming for? So when I said, yeah, we have to enable cloud connectivity and all that, so we have to actually extend the functionality of your current car, right? If you are taking the if you're taking the effort to actually do the DIY solution, build our solution and get it in your car, you should have some kind of value from it. So we have to extend the functionality of your car, and then we have to make sure that this works across all the old and cheap cars running right now in our roads, not the new and expensive cars coming out. We have to aim for, and we have to make it work in all the existing cars on the road, and the cheap cars obviously. And then we have to have cheap hardware for you to get started, and then as I said, we have to provide some value. So in all, I will give you a glimpse of what we aim to achieve, and then I'll tell you what we have achieved. Okay, just take a look at this quick video. So this mobile phone is running on mobile data, and the car is being driven. But as you can see, some data is being displayed in real time in the mobile, which is connected to a different network. The phone is not connected to the car in any sort of way. So this is what we are aiming to achieve. I will tell you how we are going to make this happen. So let's look at the existing solutions. So so what are the commercial solutions doing the same thing or aiming to do the same thing in production today? What are the commercial solutions which you can buy and use today? So let's first look at Apple AirTags, and this that ain't FOSS. This is a FOSS Meetup, sorry. So you have your normal trackers. Your normal trackers meaning you have the tile trackers and all the trackers. You get this one tracker. I hope you are all aware of this. Anyway, I'll just brief you about it. You get a tracker, you pair it to your phone, and let's take tiles trackers for example. And you can put it anywhere. You put it in your bag, put it on the collar of your pet or whatever. And if this object or if this animal or whatever goes missing, the way this works is that whenever a tracker comes into proximity with any other user or any other phone or any other tracker, it just pings its location to that device or tracker, to that phone or tracker or whatever. And as such, in the global tile database, the location of each tracker is kept updated. And now, as you can already guess, this has many shortcomings. The reason why Apple's solution is the best here is that, I hate to say it, but it is the best because iPhones are in abundance and they can tap into Apple can tap into whatever iPhone they want and actually update the location of all their trackers. With Tile and with any other alternate solution for that case, if you are using a Tile tracker, you need to have people who are using the Tile app. You have to have the Tile app installed within your phone. So say I put my tracker into a bag, I lose my bag, and then my friends over here, Ijaz and maybe they have Tile apps installed on their phones. And when they pass by the tracker can ping their phones and update its location. Okay, so now the problem comes, what if no one has installed the Tile app? Because as we know, most of you don't have, none of you have Tile apps installed in your phone, right? Because we are not using Tile trackers. With the case of Apple, they don't need to have any AirTag specific app installed. They can just use their iOS to make this. So now you can see why this is a cumbersome solution for just tracking your car. So how do we improve upon this? The next solution came in the form of connected GPS trackers. This thing is that these are small trackers. They have inbuilt GPS and GSM within them. So GSM means you can put a SIM card. It has an electronic module that supports the SIM card. So this tracker has a SIM card slot and it has a GPS module, and you can put this in whatever you want, like I said, cars or whatever, and you can have a SIM card, and this device will automatically update its own location. Again, here the shortcoming is that you don't get anything specific to the vehicle or in our case car or whatever. You don't get anything specific to the vehicle. You just get its location. That is of of course of value, but we can aim a bit more higher. So next you have Fleet Track. This is like a startup operating just to solve this problem. But here their solution is that they don't have any plug and play solutions or DIY solutions or any open source solutions. They have this device that can actually be fitted into the car with the help of a mechanic, and then that has a SIM card inside it. It will connect with the vehicle and also provide live location. These are the commercial solutions which we have in production right now. And then I'm giving an honorable mention to OpenPilot by Coma AI. Coma AI is a company founded by George Hotz. I don't know if you've heard of him. He was the first person to hack into jailbreak the iPhone. But yeah, whatever. OpenPilot, what it does is that it is actually a totally open source product. You can actually go into OpenPilot's GitHub repository and view the thing. The thing is that they have an Android phone. You can see an Android phone here. This is called the Coma device because the company is named Coma, so the device is named Coma 3. And this can actually fit into the windshield of your car, and this can actually connect to the internal systems in your car using a jack. It is called Panda. You can actually, the thing can actually connect to your car, and when you just mount this device in your car, the car becomes self-driving. I mean, just think about it. You just put an Android phone in your current car, and the car just becomes self-driving. Of course, then this is the OG solution, right? But no, because in order for this to work, you need to have very expensive cars. So what OpenPilot actually does is that it actually taps into the ADAS systems in your car. If you have driven cars with cruise control systems or lane keep assist systems, these have sensors in the front and cameras on the windshield. So what OpenPilot does is that it taps into these feeds and it adds a layer on top of those feeds with its inbuilt cameras. There's a camera here and there's a camera in the back of the device. So it does that, and then it uses that info to drive the car. And also another thing is that in order for this to drive the car, there should be motors in the steering wheel. That is, the car should be computer controlled, or else what can I say? If there is no way to give inputs electronically to the car, then you can't just simply control the car, right? So this also needs expensive and specialized cars, and Coma needs to support the cars in order for you to get it working. So again, this is not a cheap solution by any means, but of course it is DIY and open source. So what is our solution? So our solution uses mainly just three components: a Raspberry Pi and a GPS module and an ELM327 adapter. I will just go through each of these components in the next slides detail. So this is the whole cost, whole bill of materials of all these components. I think mounts to around 3,000 rupees, which is in a way affordable when you compare it to solutions like Comma 3, which costs around 1 lakh. I think 80,000 or something, because it's $1,000. Yeah, so whatever.
Cost around 10K plus. So your RPI is, oh, he's coming to that point, because I think the cheapest RPI we can get is about 6, 4 gigs, right? So what RPI? No, you're using a full-fledged RPI.
Full-fledged
Yeah.
RPI.
So which RPI are you using?
Model
4
3D
gigs?
Yeah,
plus.
2 GB.
Oh, 2 GB.
Yeah, the old 3 I am using. You can use.
Yeah, the 3 gigs, right?
Yeah, sure. Even if it's 4 GB, I mean the cost is still comparable to the other solutions, right? Like the
So
Comma
the
3.
problem right now with Raspberry Pi is that they've raised their costs and it's become kind of like unaffordable. Raspberry Pi is not our old Raspberry Pi anymore.
Yeah.
So now there's a lot of Chinese clones that are coming in, which are like super cheap, especially the Orange Pi. Those guys are giving like basically a Pentium PC at like 6,000, 7,000 rupees. I'm sorry, I was just saying.
Yeah, even in that case, our software is just a simple
Yeah.
Python script that runs in the Pi. You can just easily port it to.
Correct.
That is why we are making it open source, which I will talk about more later. Then so, of course, why didn't we go with all the RPi alternatives? Which we had the Pico, we had the Uno, we had the ESP32, all of that. For this simple application, you might think, yeah, you are right. For this simple application, we can actually use any of these alternatives, sure. But the thing is that we are planning to extend and work on this more. So we need a reliable platform to extend this without losing, without getting performance issues. So that's why I opted to go for a proper full-blown RPA. So now the device. So this is the device. So it is just I can just hold it in my hand, right? It is just portable. So what we want you to do is we have actually open sourced every aspect of this project. So I request you as contributors, if you can build better looking devices, we will accept your devices and put them on the repository and put them take them as the main device for our project. So this just looks like a black box of a plane, right? Which I can hold it in my hand. It's not very cute and it just doesn't go well with the aesthetics of all cars. So if you can make any solution that looks even better, we will accept it. We will just make it the main solution. Okay. It's just that you need to have all these components in your device. Okay, so now I'll just walk you through an example procedure of how to set up a device. So again, all that is in this device is this much. There's an RPA, there's a GPS module. Can you see? There's a GPS module, and then there is a push button. And in under the device, we have a power bank, just so that the Pi doesn't die on us. This much only. So I think this circuit diagram is also open source. You can actually get it on our README. So I think anybody with a basic taste in electronics can just buy these components and connect them together. That's all the device does.
So there's no real circuit diagrams. It's basically you're taking components, you're connecting it together,
Yeah.
right? So there's maybe the push button is
Yeah, the pin numbers.
Okay.
I mean, we don't need to have any confusion or anything. That's right.
Right.
Yeah. So once you set up this device, let's see how you can install the software in this device. This is a fresh Pi. I have only enabled the serial monitor with sudo raspi config, and we'll just now set up. We'll just follow the instructions step by step, and we'll set up this device right in front of your eyes. Okay.
So your Raspberry Pi is running Raspi.
Yeah, Raspi.
Can increase the font size. Yeah.
So this is 2 gigs, is it? RAM?
Yeah, 2 gigs. Okay, everything that you need is in our GitHub repository. I invite you to come check it out. So now we'll just download this and install. I'll just simply copy paste the commands. Everything is written out and documented for you. You just have to copy paste the commands, and you'll have your working device. Here I'm not doing anything, I'm just cloning the GitHub repository and installing all the required Python modules. You don't even need to know how this works in order to get started. You just have to copy paste the commands. Okay, once you get you're good to go. When you have run the check script, you will get a message saying that you're good to go and all the models have been installed and appear to working fine. That's it. And now you can go ahead and set up the device. Okay, so you will be using one device for one vehicle, right? So you can name your device. You can name your vehicle to identify it later in your mobile app. We actually remember our solution is to connect this car to the cloud and monitor it from your phone and do whatever with it. So you can just give a basic identification for this car. I just say the brand of this car as FOSS United.
FOSS United Kochi.
Yeah, sure. FOSS United Kochi. And so, what do you want to name the car? Any suggestions?
Andrew,
You can name the car anything, just give a name.
Auto.
Butterscotch.
Autobots.
Okay, so I hope you can. I'm not covering the screen, right? You can all see the terminal. All I just did is that I just copy pasted the commands. I gave a brand name and the name of the car, and I got a QR code. Okay, so now just can you please come and scan the code in our app. You can just get the app also from GitHub. You can just sign up and you can pair this car using this pairing code. Sign up.
You mean sign up into GitHub or sign up for your app?
For the app.
Where is your app available?
I'll just share the link at the end.
You can show it on the screen.
Yeah, sure. After everything else. Okay, so just scan it. Okay, we will get back to the app later on. Anyway, you can see a glimpse of what you're getting in the app right now. And now, since you have set it up, I'll just go a little bit more into how this system works. Okay, so I think that most of you might be interested in that. So we'll get back to the app later on. Just stay on with me, hang on with me for a while. So let's now look at how this actually works. So from car to cloud, obviously we have to get data from the car to put it to the cloud, and then we have to use a mobile app to get the cloud data back from the cloud. Yeah, and then we have the cloud itself. So let's first look at car to cloud. Now, how many of you have seen this port? How many of you have seen this port in your car? 1, 2, okay. So okay, 2 people have seen it. 3 people have seen it. Okay. Okay. So for those who haven't, I'll just brief you about this. This port is called the OBD. It stands for On-Board Diagnostics. It is mandated by law to be present in all cars manufactured after 1996. Okay. So your old Maruti 800s won't have it. I'm sorry. We can't extend support to the legacy Maruti 800s or Altos of the world. Sorry. But
Premier Padminis.
yeah, Premier Padminis and ambassadors don't have it. Sorry, we can't extend support for that. Okay, those are depreciated. Now
Deprecated.
Deprecated. Yeah, sorry. Okay, all other cars have this port. So this port, you might not be knowing, is hiding some little secrets for us. The thing is that your car is actually a computer on wheels. Whether you believe it or not, there are lots of computers, at least in modern cars, that enable the car to just even get moving. mechanical engineers can bluff about all the petrol engines and everything, but
It's fine, I think everyone's able to hear, no?
yeah,
Okay, now it's better.
okay. Yeah, they can bluff about all the petrol engines and mechanics, but without computers, cars won't get start or get moving. The engines won't keep running. The engines will just stall and fail. Yeah, so all those computers can have errors too. All those computers need to be debugged too, and they need to be serviced. They need to be taken care of, and whatever. So all of these computers are actually wired up to form a huge network of wires inside the car. Actually, I have seen reports stating that if you stretch all the wires out inside the car, you will get 1 mile or 11 mile long track of wires or something. There are lots of computing systems inside the car, and all of them are mapped to this onboard diagnostics port. So each of these pins in this port have a special connection. Like some pins are connected to the CAN bus, some pins are connected to other critical systems, some pins provide power and so on and so forth. But we don't have to bother ourselves with all of that. The point is that these cars, within these in the internal networks, what happens is that each car uses a different protocol to communicate. When I say each car, I mean each brand uses different protocols to communicate. So within the industry, there are like 3 protocols in use today. So let me break this down for you. How many of you here are web developers? Just raise your hand. Okay. So for a web developer, I'll break this down. Imagine you're making an extension that should be able to debug any kind of website that loads in your browser. Okay. You're trying to make an extension. So now we know that all of these websites are using a varied variety of tech stacks, be it React, Angular, Vue, or whatever, maybe vanilla JavaScript if someone's up for that, maybe WebAssembly or whatever. They are using all of that, but when the site loads up in your computer or in your browser, you should be able to, your extension should be able to identify what that site is made up of and enable you to debug effectively. So that is the kind of extension that you're aiming to make. Likewise, this device, consider it as the extension that you're trying to make. Now, imagine these protocols as the different varied variety of web frameworks. Okay. So now, what is the OBD port then? The OBD port is simply your developer console. It just gives you access to the whole source code of the site, and you can actually browse through any of the code. Maybe compile. If it is React, it may be compiled into some form. You can. So the OBD port is the console, and the device that you're making is the extension, and these protocols are the different web frameworks. So I think you might be getting an idea of how we need to unify all of these protocols and bring them together to a single point. Are you getting the gist of what I'm saying? Yeah, kind of, right? Okay. So now let's look at the situation now at which brands are using this. Okay. And again, I'm showing data right now about cars typically, I would say 3 or 4 years old. This data is totally relevant. Now this landscape has started to change, but still you can infer many things from this data. Okay. Let's first look at the brands using only the ISO 91412 protocol. As you can see, the Japanese are sticking to this protocol. I think the Japanese love this protocol. The Hondas, the Toyotas, the Marudis, Suzukis. Yeah, they love the protocol. Okay. Now what you have? Now you have the Americans. They are using a combination of CAN and SAE protocols. Then you have who's this? All the Germans and Koreans. Yeah, the Germans and Koreans are in love with CAN and ISO. They are using it as a mix, I think. And then you have then you have the other American brands. They're using all the protocols. Okay, wow. Now it's over. Okay, so what we have here now? I would say CAN is the most effective protocols. Okay? The cars with the most advanced tech have CAN. So in recent years, Honda and Toyota have also shifted more towards CAN. But Maruti Suzuki, maintaining its commitment to give Indians supercars, have still stuck with ISO protocols. But all of the other brands have moved into a mix of protocols. No one is using a single protocol. It is, even if you can figure out, yeah, this car belongs to one brand, if you Amaze and a Honda Civic, you can just say, yeah, the Amaze belongs to Honda and the Civic also belongs to Honda. So they might be using the one protocol. They may be using one protocol, but no, Civic is using CAN and what you call the Amaze is using ISO, because Amaze is a low-tech car, Civic is a high-tech car. And now when you take Volkswagen Group, this just blows away, because Volkswagen Group itself consists of many cars. You have Volkswagen, Skoda, Audi, Porsche, everyone comes under Volkswagen Group, and each of those cars uses a different protocol. So what we do, we use an adapter known as the ELM327. This is the one. Just costs around 300 rupees only. So we use this this has a female OBD connector, as you can see. It just plugs into the OBD port in your car. Okay. And now this adapter has built-in ways to detect the protocol. Basically, what it does is that it just pings the car all things. It has a list of imagine an array of all the protocols. It just iterates through each of the elements and tries to ping the car. Whenever the car responds correctly, it just fixates on that protocol, and then it uses that protocol from then on. Now we also have a library, we have a Python module known as OBD itself. It does the same thing. If you browse the source code of that module, you will understand how it's working. It's using the same algorithm. It just cycles through protocols. It's root for cycles through protocols and selects which one that works. Okay. So now we have sorted out the car to cloud front. We get the data, we get it to the Pi, and we send it to the cloud. Okay. The car to cloud part is sorted. Everyone is okay with that? Everyone on board with me? Okay. Next. Now from cloud to user. This is where I think most of you will be eager to contribute, and you will be able to contribute most easily. So the mobile app, it was written entirely by two folks, Joel and Ijaz, and the UI UX was designed by Jidin, three people sitting here. So this is their first React Native, this is their first app development project. So obviously there are many areas in which you can improve, but and then also the point is that being in the thing is easy to improve, right? I think many web developers are here might be knowing frameworks like React and all. You can easily catch up on this and you can contribute. We welcome any contributions that you might have. And now let's get into the server. So the cloud itself. Now the app just takes data from the cloud and displays it to you. It is just an interface outside to the whole system. Now let's talk about the cloud itself. The cloud is written in Rust and it uses a framework known as ActiveServe. Okay, so let's first go to the architecture of how the cloud works. Imagine you have two cars. So these two cars should be able to communicate with multiple users, right? So I can own two cars, okay, or I can be in a family which has two cars. But my mom and dad want to, my parents want to just take care of this object with the red car, okay, and I personally own the white car and I have to manage both of these simultaneously. So the architecture has to allow, again, some of you, like there, you may be familiar with MQTT, may be asking, why didn't we just simply use MQTT and do it? I will also explain that. There's no valid reason to why didn't we use it, but still I will explain it, what happened during the development cycle. Okay, so as each car joins the server or the cloud, we create a room for it. Okay, imagine a lobby in a hotel room which has multiple rooms, and each car creates and holds onto a room by itself. The car is in control of the room. The car is the administrator of the room. Okay, so whatever happens in the room, the car resides. If a car leaves, the room automatically just gets destroyed, and all the people in that room are get thrown out. And now, if people want to come in and monitor a car, let's say one user wants to come in and monitor the car, that is me. Let's say that is me, and now I can come in and I can join the two rooms simultaneously. Okay. So now, if another person wants to come in and monitor just the one car, they can also come in and join to the only one room which is required. So now, this architecture is primarily to enable live tracking of what you call in the thing that you just saw, the app showing all the details of the data comes from the car. So this architecture is primarily to do that. Now, now each car, when it holds onto a room, it will broadcast whatever data it has, like the speedometer, the RPM, whatever we get from this device. The vehicle will just broadcast in that room. So whoever is in that room can actually get a hold of that data and make use of it. And also the server is written in a way that the vehicle can whisper to one of the connected clients or connected users. Although we are not making use of that functionality, yet the server just supports it. So can be used for in future for development. Now all of this is connected to a central database, which is a MongoDB database, and all of this data coming through is also logged in the database. I will tell you what that is used for later on. Anyway, just I think, have you got a rough idea of what is how our server architecture works? Okay. So what's left to solve and how you can contribute. We are welcoming any of your contributions, any simple or big ideas that you may have. We want you to contribute to the project. So in the app, as I said, there are lots of areas to be improved. And even if you are a Figma designer, we welcome you. If anyone here is a like exclusively a UI UX designer, anyone? No one. Everyone are coders, okay. But whatever. Even if you are exclusively a UI UX designer, we still welcome you. If you can make changes to the app, we will incorporate that. Okay. So we welcome you. And then in the device, anything like I said, you can actually make the device smaller. We will accept your device, and this will be the main device from then on. And of course, here in this current version, threading is not done the most in the most effective manner. Like I'm sure Devdutt has actually just spoken about green threads. So I hope if you guys can use green threads and apply it effectively to this device, we welcome those PRs also to improve the performance. And then in the cloud, I'll tell you. There are some stuff that we can improve in the cloud as well. So why did I not use MQTT? So MQTT is like a protocol. Okay, so you can actually this is a protocol by which one device can actually publish a topic, and some other clients can subscribe to it and get the data. So again, the point to begin that I didn't know what MQTT was. Okay, I didn't know MQTT existed when I started developing. And we actually presented this as our mini project for college. So we had a very strict timeline to finish development. I couldn't explore the possibilities of MQTT. So we couldn't simply use it. But the thing is that this system is very much fit to use MQTT. The MQTT protocol is what it does is that if you have someone who can publish a topic, say, like we actually discussed about the vehicle details being broadcasted, right, just before. So if the vehicle can just publish these vehicle details as a publisher, all the clients can simply subscribe to that and get the info that they need. This like vastly simplifies the architecture. But instead of doing that, from scratch I wrote the whole thing in Rust. So again, we can actually incorporate MQTT even afterwards. So any contributions incorporating such changes are very much welcome. And then obviously any deployment techniques. We are currently using just simple Nginx and EC2 to deploy because I didn't find anything more sophisticated to deploy. I'm not using even Docker we are not using yet. So any other improvements in that area is welcome. Then optimization algorithms. If you are any lead code or DSA kings here, you can actually improve the algorithms, and we will again merge that as well. So at last, I will show you what this looks like. I'll show you what it looks like when you combine all of this together. And it's a short promo video. So I don't know if is audio available through the stream.
You'll have to connect through Bluetooth to get. Oh, through the stream it should be. But through
Here
you have to connect through Bluetooth.
Yeah.
You can keep the mic near.
Okay.
Or Bluetooth, we can connect directly to Linux.
No, I think he just keep the mic better.
question. Why is it called Alpha Drive?
So first we put the name Alpha Drive, so it looks so common, so I removed it. So now it's Alpha Drive. So, now, I'm sure there are some things that you saw didn't make sense right away. You saw vehicle health reports. Okay, what do all of that mean? Remember the database I talked about earlier in the server? That each vehicle can, any of the data flowing through is captured to the database. I think you remember that, right? So imagine you are renting your car to someone, you are lending your car to someone, you don't know how they drive, okay, and they are returning to you after a couple of days, and the device will tell you, the system will tell you how much health degradation has occurred due to their driving style in the amount of time that they have driven the car, and it will also give you how much the daily stats for that car.
So where is this calculation happening?
In the server.
Oh, okay. Nice.
Okay, so I think in a personal viewpoint, I mean personal perspective, maybe this might not make sense at first, but when you think about a fleet perspective, imagine all these self-drive car rentals that are lending out cars, right? So, in their case, this would make a lot of sense. If you give a car to someone, you don't know how they have managed it, and if you return it, if they return to you, you can actually use the system to monitor the car, and also since it has built-in GPS, you can actually track your car. Summing up all of this, what I have to say is that we are completely open sourcing the project. We don't have any intentions of closing down or keeping it proprietary or anything. Hence why I'm presenting it in a FOSS Meetup. And I request everyone to get your hands on the components and try to build a DIY device. I'm not forcing you. I can't force you, obviously. And we welcome any kind of contributions, any kind of minor or major contributions to the project which you guys can give. We want this to succeed as an open source project, not a closed source one. So we'll be waiting for our contributions. Thank you.
So I have a good suggestion here. It's great that you're open sourcing it, but nowadays people want convenience, right? And DIY, like I understand some people will be preferring that, but probably this is a good startup idea. You could start a startup that helps people monitor their cars.
Yeah,
as a subscription model. Okay. No, you don't have to close source. You can keep it open source and provide subscription service.
Is it cost that you guys do?
Yeah,
Cost. You can do a
Cost.
cost commercial open source.
You can talk
But
with
like, this
Andrew.
is a model, like for a hardware stuff, you can actually keep the software part of it. Common AI does that basically. Yeah. So the software for it is basically almost fully open source. So they make the money out of
Yeah, that thing is Common does that, but for us, if we are trying to open source, remember the OBD port I told you, right? So we have to scale the device into this form.
Yeah, you have to do that.
Yeah,
That is your.
that's the thing. So since we have to do that, that would take a lot of cost, right? So I don't know how it's going to play out.
You can slowly start off.
No,
you
thing
can
is that,
ask for funding. You can ask for. You can hire people to do this.
Yeah.
No, I think wait. Yeah. So how much? What's the minimum requirements you need for this? Because now you're using a 2 gig. Looks like you don't need 2 gigs. You don't need a full-fledged
full-blown
RPA.
RPA.
From what I saw right now, it doesn't feel like you need a full-fledged RPA.
Yeah,
to do this.
we are planning to. The thing why we added the Raspberry Pi is that now we are actually planning to get a display onto this, like a smart infotainment system which also connects to the car. So that is like the eventual aim. That's why we opted to go with the RPA, the full-blown RPA. Of course, we can use ESP32 or whatever.
Maybe you can try with something like maybe that Raspberry Pi, that 0-watt version.
Yeah.
I think that has 1 gig, almost 2 gigs.
512 MB.
Oh, is it?
The lowest one.
Yeah, I think 512 is enough for this. It should be more than enough.
Yeah, you can rewrite and it rusts.
Yeah, like
Yeah.
Oh, you can rewrite it.
But what's stopping you from unlocking your car or starting your car like
With OBD.
OBD, you can't do that because
It's like a debug port. You can
yeah, it's a debug port. You can't.
in my mobile, right? I can now unlock my car.
So what? Why can't you do that with OBD? Is what?
The central locking systems aren't actually wired to the OBD, yeah, because obviously that is for security. If they wire to the OBD, someone can just hack it. I mean, in the mobile, what they do is, if manufacturer gives you that option, what they do is that they have special access to the car. So
this is just for debugging. So for debugging, even on our computers and all that, we have a special electrical port just to get debug signals. Maybe the system won't start up, but that it's run on a separate chip also, which will be powered. So like when your laptops and all the start up, we have to do the post thing, right? It will even before the BIOS thing, that post runs, then the BIOS runs on it, right? So it's running a whole bunch of debug sequences and then debug.
So I have some experience working with teams who are doing something similar. There's a team of people who are working on this project where it's also being integrated in all these trucks. But they are not using OBD. They are keeping a device which is right in front of on the dashboard, right? Which will monitor the user also, like the driver, and keep track of their attention levels.
Yeah. I'm assuming it's much more expensive, right?
Yeah, it's just a Jetson Nano with
Oh, Jetson Nano is expensive.
Yes,
Come on.
yes, but it's expensive. Yeah.
It's like I think the
28.
what no we start the minimum Jetson Nano 4 gig starts at what 90,000 rupees.
Oh,
90.
I think so. It's a full-fledged GPU, man. It's built on Jetson. Jetson is
Open
built
Pilot
on,
actually does this right now. In the device that I told you, the Comma 3 has a front-facing camera, so I think they do it also.
sorry, not 90. The kit comes as 90. I think the module alone did, because see
20,
the module is like putting a CPU onto the they call it what they call it some kind of board. I think. No, I think it's called some attachment board or something. They have that board is like 30,000, 40,000 rupees. Then you can change the modules. You can go for So this is
20K.
Yeah, so that is 20, 25, 30K. Then the module is 40. I think the minimum 4 GB Jetson Nano is like, I think 60. I don't know. It's that expensive. So when you put the full thing together, it's like 1 lakh rupees, 100,000. Right? It's crazy.
Okay, so since you all have bear with me, and I told you would return to the app earlier. So if you have the patience and you can come down, we will demo this device that we have set up in a real car right downstairs.
100%.
I hope for all other contributions to come. Thank you.
Okay, it stops streaming now.
Yeah, do you have any closing notes? Okay, so we're going to have a demo downstairs. So it's in the parking lot over here. These guys have brought a car and they're going to plug in this whole thing and they're going to show us like how they're going to do this thing, right? Okay.
Before MBD bans it.
All right, so we'll go downstairs and we'll So I don't know.
Yeah, you can start.
Okay.
Yeah.
Okay. Yeah, you just started talking.
I know.
Right.
Just figuring out stuff. Okay. Thank you, Vishal, for the awesome demonstration. Alpha Drive looks cool. As a person who tinkers with the car, very questionably, I might also give it a shot. All right. There's, as he said, there's going to be a demo downstairs. I'll be really interested in looking that. So that's about it for this week, this month's meetup. I want to thank the venue host, NeoITO guys, for the space. Even though it is a little bit difficult to find it out, I'm really happy to. Again, I'm just saying thank you so much for being here, especially on this really rainy and gloomy Saturday. That's about it.
All right. Thank you.